guys, we are in Unit 4, Topic 4. So we are going to take chemical formulas and turn them into names. So far we've done names and written formulas. We're just doing the exact opposite. Now if you notice, my paper here, if you can tell, is written sideways because we're going to want a little bit more width because we're going to be making a flow chart and they've got lots of options. I find that the other way helps, so if you want to turn your paper 90 degrees, if not, that's fine. All right, so the flow chart is going to be a series of questions. You're going to ask questions and go based on wherever the answer is. So the first question, you're going to look at your chemical formula and say, what's in it? What's in the chemical formula? So this is where we start. Now I'm going to cover some stuff from old units just because there are lots of chemicals, not just ionic compounds. So there could be either one type of element, or there could be two or more types of elements. If there's just one type of element, like for example Cl2, right? The way you're going to name that is just use element's name. It's that easy. So I'm going to go ahead and even make this a little cloud because it's so easy. Just use the element's name. So for example, Cl2 just has chlorine in it, so that's called chlorine. I don't do anything. I just tell my reader what's in it. If I have two or more types of elements, then it's a little bit more complicated. So we're going to do this question, what does it start with? For those of you that love English, you know that we're not supposed to end a sentence with, that is a preposition, but please don't tell your English teachers on me. Okay, so you're going to look at the chemical formula and say, what's at the very beginning? So what does it start with? And we have a few options. So if it starts with hydrogen, it doesn't matter the numbers after it, just if it has H at the beginning, then this is an acid, and it's not covered in this course. Okay, so we're done. No acids. So if it starts with hydrogen, we're not going to learn how to name it. All right, so now we're going to say it could either start with a nonmetal, or it could start with a metal, or NH4, or pH4. Now I realize nitrogen and phosphorus, they are nonmetals. So if it starts with NH4 or pH4, this is going to be more important than this nonmetal. Okay, so look for that. Look for if it starts with a metal, NH4 or pH4. If it starts with a nonmetal, besides if it's got a H4 right after it, then this is a covalent compound. We have learned about naming these before. So this is when you use prefixes to say how many, and specifically how many atoms, and then no mono with first element. And then change ending of second element to IDE. And this is from a previous unit, so you already know how to do this. Okay, so this is the covalent naming. You can go back to Unit 3 if you want to look up how to do that. If it starts with a metal, an NH4 or pH4, then it's ionic. So this is what we've been covering this unit. So if it's ionic, the way we're going to do this is name your cation, then name your anion. All right. So first, we're going to start with the cation. So this is your first thing, and this is your second thing for the name. You always say cation, then anion. The first step, name your cation. What does your compound start with? So there are a few options for this. Your compound could start with NH4. Your compound could start with PH4. Or your compound could start with a group 1A, 2A metal. So that is the first two columns on the periodic table. Or if it starts with zinc, silver, cadmium, gallium, or aluminum. You're going to follow this line. If it starts with any other metal, you'll follow that line. All right, so let's start with this. If it starts with NH4, ammonium. That's the name. Just write it. It starts with NH4. If it starts with PH4, then it's phosphonium. Just, you write that name. These are the only two polyatomic cations. So you're saying if it's either of these, well, it starts with a cation, and if that cation is a polyatomic ion, it either is NH4 or PH4, and you're just going to name it as is. If it's a group 1A, 2A, zinc, silver, cadmium, gallium, or aluminum, the thing about these is they have set charges. So if you look back to that periodic table I gave you, it'll show you. So a while ago you got this periodic table, right? And these are our non-metals, but the white ones over here, so group 1A, 2A, or this group of 5 metals, they have definite charges. So whenever you list them as a cation, your reader automatically knows that, say, if you just start your compound name with the word beryllium, your reader knows that's going to have a positive 2 charge. If you just write potassium, then your reader knows that's going to have a positive 1 charge. They don't have to wonder what the charge is. These, and these all have set charges. So let's write that. Set charges. So just name your metal. You don't have to tell your reader anything else about it. They know what the charge on that cation is. Let's make this arrow go down a bit. Okay. So if it's any other metal, what I mean by any other metal is anything in this blue area here. So these are your transition metals except for these 3, and your p-block metals except for these 2. If it's any of these blue metals, then you have to follow this rule. So we can even write this in, blue metals. So what you're going to do is name your metal and list your charge with Roman numerals. Here's the thing. You have to figure out what the charge is. It is not going to be given to you in the formula. You have to do a reverse chart. And I'm going to go through that with you later in the notes. So you'll have to do a reverse chart to figure out what your Roman numeral charge is. All right, so here is how we name our cation. So now, once our cation is named, all these steps. Now we need to name your anion. So what does your compound start with? This is your cation. We already did that. So we named all these. These are our cations. Now we need to name our anion. What is our thing with our negative charge? And what we're going to do is we have two ways, two possibilities here. So I want you to count how many elements are left that aren't, oh, there's no T, aren't in your cation. And you have two options. You either have one thing left or you have more than one element left. So if you have one element left, it's going to be a nonmetal. So name your nonmetal. But change the ending to IDE. This is only if you have one element left. Okay. If you have more than one element left, if you have 2 elements, 3 elements, 4 elements, then you have to name your polyatomic ion. And you're going to get this from your chart or from your list, right? There's a big deal here though. Do not change the name. Whatever the polyatomic ion's name is, that's what it is. You can't change it. When you change over here, you're telling your reader that this is not elemental. It's in a compound. This isn't elemental. So it's ite or ide, whichever ending it has to keep that ending. So let's do some examples. Make sure you have this chart handy, and I would switch to another page so you can reference this chart. I'm going to reference this chart as well. For the examples that I'm doing, I'm only going to do ionic examples. We've already done covalent compounds, we're not doing acids, and we've done one element compounds. So, all right, first example, Ca3N2. All right, I'm still going to start at the beginning of my flowchart. So I've got Ca3N2. So what's in the chemical formula? Do I have one type of element? Well, no, I've got calcium and nitrogen. 2 or more? I do. So what does it start with? It starts with Ca. So I'm going to come to this periodic table and I'm going to look for Ca. Ca is right here. And if I look up top, it highlights the alkaline earth metals. So I know that this starts with a metal. Calcium is my first metal. So it starts with a metal. It's ionic, which I already told you it was going to be. So we have to name our cation and our anion. So what does your compound start with? What's your cation? Did we start with NH4? No, we started with a Ca. Did we start with pH4? No, it was a Ca. Is it a group 1A, 2A, zinc, silver, cadmium, gallium, or aluminum? It is. It's in 2A. It's in the second group on the periodic table. So I'm going to use those rules. It's got set charges, so just name your metal. Great. So this is calcium. I've named this part of my chemical formula. So you can even like scratch that out if you want to keep track of it. So now this is what I have to name left. So I've done this. I've done my cation. So then follow to name your anion. Okay? So now I'm naming my anion. Count how many elements are left that aren't part of your cation. So I've named my cation. I only have nitrogen left. That's one type of element. So I have one type of element. So I name my nonmetal, which is nitrogen in this example, but I change the ending to ide. So instead of saying calcium nitrogen, I say calcium nitride. My next example is ZnTeO4. So I'm always going to start at the beginning of our flowchart. What's in the chemical formula? one type of element or two or more. Well, I've got zinc, tellurium, and oxygen. So I have two or more. What does it start with? Zinc is a metal. You've probably seen zinc before. It's silver and shiny. You can also look it up at ptable.com and it'll tell you if it's a metal or non-metal. So it starts with a metal. So we know it's ionic. So we have to name our cation, then we're going to name our anion. So let's name our cation. What does it start with? I start with zinc. So what does it start with? I go here, zinc. I have another one that has a set charge, so I just name my metal. So this is zinc. I've already named that part of the compound. So now I have to name this part of the compound. So I've done my cation. All of these are cation parts. And now I go over here, and these are all my anion steps. Count how many elements are left that aren't in your cation. Tellurium and oxygen. So I have 2 elements left, which is more than 1. So name your polyatomic ion. Do not change the name. So I need to find TeO4 on my list of polyatomic ions. So on this worksheet, I'm going to go for my anions in red and look here for TeO4. I don't see any. TeO4. And I'm going to come down here, and there it is. TeO4, tellurate. So TeO4 is tellurate. There it is. There's my name. My next example, NH4 2S. Okay, I know that it's going to be ionic, and I know that I'm starting with NH4. So let's skip to that part. Ionic, it goes to NH4. So we come here. We know NH4 is ammonium. So this is named ammonium. We've named our cation. Now we just have to name our anion. So now we come over here. Our anion, name our anion. Count how many elements are left that aren't in your cation. I just have sulfur left. So name your nonmetal, but change to IDE. Instead of saying sulfur, it's sulfide. For this one, we've got cobalt, silicon, and oxygen. So you know you have 3 or more elements, and the first one is cobalt, and then you can tell that SiO4 is grouped together. Since we're starting with cobalt, which is a metal, we're going to start here, and then we come here. Is it NH4? No. pH4? No. Cobalt is not in group 1A or 2A, so let's just find it on the periodic table to show you where cobalt is. It's right here. So it is not group 1A is lithium, sodium, potassium, etc. It's not 2A, beryllium, magnesium, calcium. It's over here. And then if we compare that to what I gave you, so over here, it's a blue metal. So that means we need to do a reverse charge chart. So I want you to write in your notes, reverse charge chart. Okay, when we're doing the reverse charge chart, we're going to name our metal and list the charge with Roman numerals with the reverse chart. Here's the thing. I'm just going to put cobalt, and then I'm going to put a blank space for my Roman numeral because I'm going to come back to this. So leave blank initially. We're going to do the reverse charge chart last. So we've now named this, even though it's not fully named. It's not done because I don't have my charge of cobalt. But for now, I'm going to skip. So we go here, name our anion, count how many are left. Do we have 1 or 2? So after cobalt's named, I have SiO4. Now I have 3 of them, but you only look inside the parentheses if there are parentheses. So we need to find SiO4, which is going to be a polyatomic ion. So we know we're in the anions, so we're in red, so we're looking for SiO4, SiO4. So we go to the top, SiO4, we've got an SiF6, close, not right, SiO3, not quite, SiO3, SiO4, right here, orthosilicate. I want you to ignore this one. It's there, but Nobody really uses that name, so we're going to use orthosilicate. Orthosilicate. So that's named this part. And this had a 4- charge on it. And we don't know what charge this cobalt had, okay? So we've named these two parts. Now we need to do our reverse charge chart. So we know that this is our name, so we're going to do our chart. So when you do your chart, count how many of each ion and draw as circles under. I know I have 4 cobalts. 1, 2, 3, 4. I know I have 3 orthosilicates. 1, 2, 3. Okay. I'm going to write in anion charges in circles. So my orthosilicate had a 4-, so I have a 4- on this one, 4- on this one, and a 4- on that one. Total anion charge. 4-, 4-, 4-, this is 12-. Make equal but opposite total cation charge. So that means over here, this total is going to be 12 plus. Just distribute positive charges. So I need each of these 4 to have some charge that's the same on each that's going to add up to 12 plus. So since I have 4 parts, I just take 12 plus and divide it by 4. So 12, you can think divided by 4 is going to give you 3 plus. So that's what goes in each of these. So each cobalt has a charge of 3 plus. Whatever goes in here, that's your Roman numeral. So here's your name, cobalt-3 orthosilicate. All right, guys, here are 4 examples. I want you to work these out on your own. So you can go ahead and freeze, take some time to answer these, and then we're going to go over what the answer is. Make sure you talk to me if you have any questions. Here are the answers to those 4 practice problems. Hope you got them right. If you did not, be sure you talk to me about what happens so we can go over and fix any problems you have. Otherwise, I'll see you in the next set of notes, guys.